Hey everyone, it's Justin again. I am so glad you're here because I've been itching to get started with the first level of Power Play. Remember that new video game all about exponents and simplifying the unsimplifiable? In our last lesson, we kicked off the exponents and radicals unit by diving into the tutorial level of the game where we reviewed how to write exponents in expanded form and how to evaluate them. But now that we've got a handle on the basics, I feel confident that we're ready to start playing the real deal. So what are we waiting for? Let's power it up!
To survive this level, you must master the first of the 5 key properties of exponents, the product of powers property.
Oh, I can't believe I almost forgot. There's a discovery activity in your PDF that you need to do first. In this activity, you'll be expanding powers to discover what the product of powers property actually is. It's very important that we do this discovery activity first before starting the level. Pause the video here and complete the activity now if you haven't already. Based on the first example row, I know that to expand, I can use the exponent to see how many times the base should be multiplied by itself. 2 to the third means there are 3 2's multiplied together, and 2 to the fourth means there are 4 2's. Then I see that the example brought all of the 2's together without parentheses. That's probably because multiplication is the same no matter what order you do it in. The parentheses aren't necessary, but they were helpful for organizing each part of the expression separately. The next column asked how many total times the base was multiplied together. 1, 2, 3, 4, 5, 6, 7 total 2's being multiplied, which matches what the example says. Okay. So to rewrite that with one exponent, we would have a base of 2 with an exponent of 7 to show I want to multiply it times itself 7 times. Once I understood how the first row was completed, it helped me to do the same thing in the rest of the rows. If you were stuck before, now is a great time to pause and try again. Once you've finished, you can check your answers against mine. Did you expand everything correctly? Find how many total times each base was being multiplied together, and then rewrite it with the correct single exponent? Were you able to identify any pattern between the exponents we started with in each expression and the single exponent we ended up with? Let's put your prediction to the test with a new example. Here we have v to the 5th times v to the 8th. Make a prediction. How can I rewrite this with a single exponent? Let's see if you're right. Remember that an exponent tells us how many times to multiply the base times itself. So this first part means to multiply v together 5 times. And this means to multiply v together another 8 more times. That's a total of 13 times. How else could we represent multiplying v times itself 13 times? Yeah, v to the 13th. Since both of these exponents have the same base, the second one just adds even more additional v's to our expression. And just like it adds more v's, we can also get to our final exponent by adding the original exponents together. 5 plus 8 makes our final exponent of 13. Was your prediction correct? The product of powers property is really useful to making operations like this more efficient. We can represent this property more generally by saying that x with some exponent a times x with another exponent b can be simplified to a single instance of x with an exponent of a plus b, the sum of the original exponents. If having a lot of variables altogether feels a little overwhelming, you can rewrite this property in a way that feels better for you, like using shapes instead of variables. It's really important to keep in mind that this property only works when the exponents have the same base. If we took that same example with v to the fifth, but then multiply it by k to the eighth, how would that change things? If we expand it, I have 5 v's and 8 k's. Can I combine these and rewrite them with a single exponent? No, I can't. This is already fully simplified. So make sure you check the bases of your exponents before you try to add them together. Now, let's put this product of powers property to work and jump into power play. We have 4 to the 7th times 4 to the 3rd, and we need to rewrite the expression with a single exponent. Give this problem a try on your own first. Remember that you can use the product of powers property, but you can also expand the repeated multiplication to help. Pause the video and give it your best effort. The product of powers property says that when we have components with the same base being multiplied together, we can add their exponents. Do these elements have the same base? Yes, their bases are both 4. So I can add the exponents. So this would be 4 with an exponent of 7 plus 3, or 4 to the 10th. Notice that the base doesn't change. We don't have to multiply 4 times 4 together because that's what our exponent represents. It's already built in. Expanding can help double check your answer. 4 to the 7th means 4 times itself 7 times. Times 4 to the 3rd is 4 times itself 3 more times. In total, I have 4 times itself 10 times, just like what we got with the product of powers property. So we can be extra confident now that 4 to the 10th is our final answer. We did it! Okay, next problem. This one says to simplify the expression as much as possible. And we have a to the 6th, b squared, times a b to the 3rd. Whoa, there are 2 different bases in this problem. What do you think that'll mean for our final answer? Because there's 2 different bases, I'll have to have one component where the base is a, and one component where the base is b. Moving the parts of this expression with like bases next to each other might help us stay organized. Can we even do that? Yes, everything here is being multiplied together, and multiplication is commutative. That means the order of the factors does not matter. Let's start by keeping a to the 6th first. Then I want to move this a over next to it. Remember that an exponent only applies to the base under it, so this exponent of 3 goes with the b. This a does not have an exponent written with it. Then, for the b's, we have b squared times b to the 3rd. That's better. The product of powers property says that when like bases are being multiplied, we add their exponents. But this a doesn't have an exponent. Or does it? If I have an a all by itself, then there's just one a. We can even write in an exponent of 1 ourselves to make sure we don't forget it. Now that we've rearranged things, pause the video and try to finish simplifying this on your own. According to the product of powers property, I can take my 2 elements with a base of a and add their exponents. 6 plus that sneaky 1 makes a final exponent for a of 7. Doing the same for the base of b, 2 plus 3 makes the final exponent of 5. For our final answer, within a term, we always want to put our bases in alphabetical order. So a to the 7th first, followed by b to the 5th. Remember that variables also don't need multiplication signs between them, so most commonly you'll see this written without it, like this. Yes! All right, I think this is the last problem in the level. Again, we need to simplify the expression as much as possible. But now we have g to the 3rd, h, j to the 8th, times g to the 10th, h to the 7th. Okay, sure, there are more variables in this one, but we can do this. Since this is all multiplication, let's rearrange the expression to put all of the like bases next to each other. Pause the video now to rewrite the expression in your guided notes. For the g's, we have g cubed and g to the 10th. For the h's, we have just a plain old h and h to the 7th. For the j's, we have j to the 8th and, oh, that's actually the only j. Do you think that's a problem? No, not at all. In fact, it means that the j part of the expression is already simplified. Remember, because multiplication is commutative, if your g or h components are in the opposite order from mine, that is totally okay. It still means the same thing. Go ahead and use the product of powers property to simplify and combine as much as possible here. Don't forget that you can always expand everything if you want to check your work. G cubed times g to the 10th becomes g with an exponent of 3 plus 10, or 13. H by itself really has an exponent of 1 times h to the 7th becomes h with an exponent of 1 plus 7, or 8. And we didn't have to do anything with j because it already has just a single exponent, so this stays as j to the 8th. My variables are in alphabetical order, so this is my final answer. The product of powers property tells us that when two factors with exponents are being multiplied, and they have the same base, we can combine them into a single power by adding their exponents. We did it! Level 1 of Power Play bites the dust. By now, your product of powers discovery should be complete. Once you finish up the notes that go along with this video, you'll move on to the final task of this lesson, the online practice. I can't wait to find out what lies in store for us in level 2. I have a feeling these levels build on each other, so until then, keep practicing so we can harness the power of the power. See you next time.